Hey folks, welcome to Feb 14, 2023 SIG Node weekly meeting. We have a few topics on the agenda. Let's get started. So the first one is from Sergey. So basically it's an announcement that we are tracking 23 kits this release. So that's a lot. And I hope people start working on the implementation so we can get them out soon. So we missed a few kits because we were not able to get either reviews or the updates in time. So we can continue working on those kits for the next release. Any questions or comments? Okay. Let's move to Peter's topic because Sergey is going to join late. Peter, you want to talk about the automatic C group driver matching proposal?
Hi. Yeah. So this issue came up a little while ago, and I wanted to talk about. So basically, for some background, the state of things now. When the kubelet starts up, it you specify a C group driver, and then you do the same thing with either containerd or cryo. And if they mismatch, then some weird behavior can happen, like cryo fails to create any containers. It just refuses to if it detects the paths are wrong. So I wanted to talk about potentially updating that. I came up. It seems like it would be possible to do it without any CRI changes. So I wanted to discuss kind of the approach and see if people felt as though it seemed realistic. So basically, the kubelet right now has common patterns for how it specifies the pod C group. And so theoretically, whenever a run pod sandbox request comes in, it could the CRI knows like what it's asking, because if it's a system DC group driver, then it'll try to put that pod into a slice, and then if it's C group FS, then it'll have a path not that doesn't specify slice or scope. So my thought was having the CRI just automatically detect if there's either slice or scope in the name with a dot, basically, to make sure that it's like a path extension, and then decide on the C group driver from there. The overall goal from cryo's perspective, at least, is to reduce the number of configuration options that are like duplicated with the kubelet. There are a number of them that we had in the past, and so we've kind of been in the process of deprecating some of those, and C group driver is one that I think we could be auto detecting, and then deprecate the configuration option. So I just wanted to run that by everyone and see, if you can think of any potential pitfalls there. I don't think we would need a KEP with that approach. Cryo could just adopt it, and if containerd wanted to as well, that could be done. So what do folks think about that?
So I just wanted to say, like, first of all, totally +1 like on this overall goal, because I myself have like debugged many cases where the C group driver has mismatches, and it actually doesn't fail, like it tries to work, and then kubelet basically creates a C group FS thing, and then like a runtime creates a system D one, and then they're mismatched, and all types of crazy stuff happens. So it's kind of a really bad scenario that happens and wastes a lot of debugging time. My only question is, like, with your proposal, which one are you asking will be like the source of truth, like the kubelet configuration or the runtime configuration?
So in this case, and this actually will spawn a follow-up, but I'm going to answer that question directly, is in this case, the kubelet would be the source of truth. So the kubelet would pass down the pod C group to runtime, and the runtime would interpret which C group driver to use based on that.
My only concern is, like, if for some reason that format changes in the future, should we make it more first class and pass the driver name over the CRI? Or another alternative is like runtime exposes that back as info, but that's the other way around.
Right. So this actually will. So there's a follow up. So Sasha and Marcus and Christian and I chatted about this before today because this part of this almost kind of ties in with some future work with pulling C group management into the runtime, like the pod C group management, but also kind of ties in with the class resources work because there's going to be some extension to the runtime status call that the kubelet calls into the runtime asking for, whether the network is up and stuff. And so we could extend that call to also pass up the C group driver. And I'm open to that as a way to do it more in a first class way. My thought is, right now the C group, like we could do this automatic detection and we wouldn't necessarily need a KEP or a CRI changes to do that. And that, in the future when it's extended, it could be, the responsibility could be switched, or we could just get started on the, more legit path now. So yeah, that is a consideration is, who should actually be the ultimate owner of the C group manager field? Like, should it actually be the runtime? Should the runtime really be the one in charge of the C groups and then the kubelets into that? That is an option. So that is kind of part of the conversation as well.
Yeah, I think right now both the entities touch it, so it's kind of no clear owner. So I think that this sounds reasonable to me. This plan doing it short term and then revisiting it with runtime info. Derek has a question in the chat. What are we looking for in the path that distinguishes V1 or V2?
So we don't need to use the path to distinguish that because the node will be I assume we'll just use like lib containers like is C group FS function. So like if sysfs C group is mounted as C group FS, that we would just use as what do they call it? C group 2 FS or something. So we would just use that as the determining factor for whether it's V2 and then otherwise use V1. So that isn't necessarily an option. We pretty much auto detect that now because the kubelet doesn't tell the runtime to use V2 path. It just lets the runtime make that determination, and it itself makes that determination when mounting the pod C groups.
I think that makes sense. My only slight concern here is like the runtimes, at least I don't know on I don't know about Cryo side, but on containerd side, they already have configuration for the C group driver, right? So like, would that be just ignored then if they don't match, for example? Like, say you configure your containerd to be C group FS, and then you could configure your kubelet to be systemd. Does that mean we just ignore the runtime configuration setting in that case?
Yeah, so that does bring up a question, especially if we end up using the runtime status and have the runtime be the source of truth for the field. Then it would actually be kind of like a horseshoe thing where we currently use the field in the runtime, and then we would go to not using the field in the runtime and be based on the kubelet's field, and then we would horseshoe back if we had the runtime be the source of truth. So that might be a little bit awkward. So if the eventual goal is to have the runtime be the one responsible for the C group settings, then it might actually make more sense just to keep the field in the runtime and instead go the legit path of setting up the KEP and actually having the runtime status inform the C group driver of the kubelet. That is an option as well.
My understanding it is, I think this is a little bit like the startup ordering, right? So you could be like sometimes could be the runtime start first, and also config both the runtime and the Kubernetes can config the path. So who should be the initiate and config the source and also pass down to another entity, right? So another, like the Kubernetes to the container runtime, Kubernetes start first and pass that, and or it is the runtime first and kubelet read from that config. So I think maybe there's also implied we have to also define to some extent define that order. Who should be the source of the truth here?
Yeah, well, I mean, in kubelet execution now, like it waits for the runtime status to start, doing things because it is pinging on waiting for the network to be ready, for instance, which is solely the responsibility of the runtime. So there is already that dependency, which is the opposite of the way Docker was, where kubelet would start Docker with the Docker shim, but now it's like the other way around where kubelet is waiting on the CRI. So to that degree, it does make sense to have the kubelet also be waiting on the runtime for the C group driver to be ready, for instance, so that it then can start initializing.
Yeah, that's good point.
For CRI, it's easy because it serves only the Kubernetes. But for Containerd, it will be a bit more complicated because Containerd can support both at the same time kubelet and the Docker CLI interface.
Yes.
So in that sense, for Containerd, it's a bit easier to be the source of the truth.
Yeah. But I think sorry to David's comment about Containerd. So I think what would be the upside of this feature's simple change would be that at least in Containerd to be able to give a reasonable error message to the admin that now it's like cross-configured or something's wrong there, instead of the current very problematic behavior when Containerd just does something which is not what the user expects.
Yeah, that makes sense. The one other comment, and I don't know, honestly, I just want to bring this up as something like on Containerd, the systemd driver is configured actually, I think, on the runtime class level. Like, you can have a different runtime class, I believe, with different, different drivers potentially, right? So I don't know, maybe some people do something like that where they have some sync there. I'm not aware where we use something like that, but just something to be aware of.
Yeah, and then to that degree, it makes further sense to have the kubelet. Well, I guess. So do you think, given that capability, do you think it makes sense for the kubelet to be extra flexible with a C group driver where, like, if we're living in a world where the runtime is the one that tells the kubelet what C group driver to use, but the Containerd has the option to use multiple C group drivers, should the kubelet, instead of having it like be a runtime status call, should it be able to multiplex like per runtime class or runtime status call versus like, in the runtime class, or should we just not, is that a feature that we feel like supporting in the kubelet? Cryo can't do that now. It just chooses one like the kubelet does.
I don't even know how that would work. I guess if I understood the comment, on a runtime class setting, you could say use C group FS versus systemd pass, but the kubelet is the one creating the pod C group. So you'd be putting, I don't even think that would work. I'm confused how that would.
Well, you'd have to ask each time basically, or, the kubelet would have to ask or remember the specific C group driver for each.
The entire clause hierarchy is, I don't think it would work. I don't think we should try to get fancy on this.
Yeah. I mean, because
That's
where will
fine.
what will the kubelet? It needs additional changes to the kubelet, right, to even work. Yeah.
Yeah, that makes sense. I don't think it is kind of a crazy use case, but just wanted to call it out as maybe something some folks do. I'm not aware of anything like that. The scenario is like, for example, we support gvisor, right? And so gvisor has its own systemd C group setting that you need to apply, right? That's done under like a different runtime class. Like for us, we just match it, right? If we enable systemd in kubelet, we'll also enable it for all the runtimes, but maybe other folks don't do that. I don't know. It's why I'm bringing it up.
Yeah, I'm fine without that. So it sounds like we are leaning towards having the runtime be the one to report up, and instead of having runtime auto detect, maybe we should just go the legit path of like, having the runtime report up through the runtime status, what the C group driver is going to be, and then have the kubelet auto detect and just choose one, not have, multiple instead of, yeah, so then we can, maybe pursue something like that in a KEP for 128 at this point. Yeah, so unless there's any other thoughts on that, that kind of gives me information to move forward. So we won't do this auto detection because it would just involve deprecating a flag that they'll then immediately reintroduce. So instead, we'll pursue this in the future in a more legit way, in the, having the runtime report up to the kubelet what cgroup to use. So, yeah.
All right.
I would like to comment also about another thing, which is also common misconfiguration between those two while we are not. So the C groups is one, but we have CPU set for infrastructure cores. So we have two independent options, one on runtime side, one on the kubelet side. And we probably also can put it in the same handshake protocol as part of WebKit.
Maybe we can open an issue and gather all these and then build it off there. Right. Thanks for the discussion. We can move on to the next topic. So next is Deep and Yuan discuss decoupling no execute taint manager from node lifecycle controller.
Okay, and can you hear me well?
Yeah.
Yeah, firstly, I want to give a quick self-introduction since I'm new to the group. So I'm Yuan Chen from Apple, and I've been working with Deep and also other folks you may be familiar with, like Containerd folks, Michael and Derek and others. So I've been working in the Kubernetes and for more than 4 years. I used to contribute a lot to the SIG scheduler and the scalability group. But now, I'm more interested and also contribute to the SIG and the Node, and hopefully can get more involved and contribute to this group. So can I share my screen?
Just a sec, I'll have to give you host.
Okay. So where I'm getting then let's see. Seems I still don't have the.
Okay, can you try now?
Okay, it's working now.
Yes, I can see a screen. Thanks.
Okay, so let me decouple this. Okay. So the idea and Deep and I discuss a lot based on some use cases and our observation is the current and the node lifecycle and the controller basically combine two separate functions into one, right? One is apply and adds the node taints to the nodes, but this is only a subset of the taints. The second one is this and the taint manager, right? It acts on this and no executive and evictions, but this can be applied to any and arbitrary and taints. So this probably is not the ideal way to implement it, right? One is apply or add the nodes, another is act on any and a set of the taints. So what another thing I want to also mention, Deep noticed is, of course, so far you can enable the default and the taint manager, right? Apply and whatever and custom one. But from the Kubernetes 1.27, and this and the flag and will be dropped off. So there's no way to disable it. So what so any questions on this, or Deep, you have anything to add to the current status or the background or introduction?
No, go ahead. Thanks.
Okay, so so that's the current status of the background. So what we are proposing is basically decouple refactor the current node life cycle and controller implementation, right? Decouple this function. So basically decouple this and the taint manager. This is and evict the ports based on the taints and from the current node lifecycle and the controller. And so make them two separate functions. We can manage them separately. Of course, one way and then the benefits we see here is we can have more structured, flexible, consistent. We manage these two and the separate function, right? One is add a certain set of the node taints to node, and another one is act on these taints to decide and how to evict the ports. So another thing we want to mention is, the use cases here we have seen and from the some the real workloads introduction is for the complex workloads, right? And in particular, some stateful workloads and have the local storage. And definitely they want to have some custom and more flexible policy to determine whether or not when to evict ports based on the taint. And currently we can use the taint toleration. We don't want to just evict, right, some stateful ports, and which have the local storage on a node when a node is unhealthy or networking other issues. And so far we just rely on the taint toleration to do that, but taint toleration are not flexible enough, right? The application controller may want to, depends and look at the class condition, also the workload characteristics and the different requirement, and more dynamically decide, whether or not evict the ports. So from that perspective, for example, and in our cases, the users or the application owners want to implement a custom and port eviction controller or manager. So if we decouple these two and we have more and flexibility and we can disable the default over the port eviction manager and apply and use any of the custom and controllers. Another reason I mentioned is since 1.27, the flag will be removed. So if there are no changes, and it will be very hard to support this advanced or custom port eviction policies. Okay, so this is basically the idea. And again, any question, comments, or Deep, you have anything to add or?
When you say
No,
decouple, you
just,
mean,
oh, go ahead.
when you say decouple, what does that mean in practice? Does that mean I can turn off the function and not have it run in the kube controller manager? I'm decoupling it in a separate binary. What is meant by decouple?
Okay, so by decoupling, and Deep, correct me or add anything. We basically mean so far is in the code base, right? It's the implementation is a single and controller. In the lifecycle controller manager, you call this, right, port manager. So by decoupling, we mean is have completed two separate controller or managers, the code base, right? Of course, then you can disable, enable them separately.
Yeah,
But
like
it-
exactly. The overall idea was we do want the node lifecycle controllers ability to react on node state and like apply these taints, but not necessarily enable the taint manager to basically take action on any arbitrary no execute taint. That's like beyond the job of the node lifecycle manager today. So it's kind of like aligning this model more to like the scheduler model, where the scheduler acts as the controller that takes care of treating the no schedule taints applied by the node lifecycle controller, as well as any other controller, right? So basically align the no execute taint manager as an independent controller, more similar to how the scheduler acts on no schedule taints. Basically.
All right, let me just try to repeat that back then to make sure I understood the response. So you would want to have these as distinct controllers that are both enableable in the existing kube controller manager binary. But for your use case or folks who have similar use cases, you would want to be able to disable one of those controllers in the existing kube controller binary, and then presumably have a way of fulfilling that use case in your environment with your own custom solution, correct?
Exactly.
Okay.
Yeah, I would say, the first thing I could point out, since the current one combine these two, right? and you add the node justice and the unreachable and not ready, but functionality wise, right? And the action is separate. So even from the implementation or I think maintenance perspective, it would be nice, right? And have them separate. Like, I've been working on the scheduler side. The scheduler look at those scheduled tent, right? It doesn't matter where the tent added or when to add it, and it act on those. So it would be nice, yeah. But of course, our use cases is, we really want to support and more advanced customer and we support the tent and the eviction policy. We believe that's probably, there will be, general and requirements from a lot of use cases.
I'm not necessarily against this idea. I think but I just want to mention one thing. So originally, why those tend, it is in the node lifecycle management controller. It is just because it is just those tend also serve node lifecycle. And so, so now you want to expand that to have other tend. So you want to central controller to apply the tend beyond node lifecycle, which is the good. If that's the case, then separate that maybe is the good idea. But there's also, I want to say that imply potential a little bit, maybe people don't care, some people, but it may potential have the slow down some of the, because if you have to queue in a lot of those tents and apply, and you end up have the more like the reconsolidation loop, and that potential could have some a little bit performance things. So I'm not sure what kind of the tend you want to apply beyond node lifecycle on top of this, because even like the new node execute, to me, it is node lifecycle to some extent. So that's why I'm not sure what the kind of tend. Can you introduce more, like what kind of use cases we can justify this one? And another thing it is, I don't think about the there's the trade-off always. So I'm not sure necessarily you break more controller and more things and more will be good design. Yeah, and if you have like the really good reasons, because there's the, like for example, you have the more modules, you have the separate binary, more binaries, then you definitely increase of the resource usage, right? So that's why I want to know more, because I think about the all the node tends you are mentioning here, still it is related to node state, which is node lifecycle state. And I didn't see any other use cases here. So can we expand that one more? What kind of you wanted to do? Because when I want to evict all the pods on the node, to me, it is part of also node lifecycle management to some extent. So that's why I want to know more beyond those things.
Yeah. So I can take first, then Deep can add more comments and or ideas here. So firstly, I agree with, the performance concern, of course, is always, and I think generally speaking, right, you put everything together and it will potentially have a better performance than, you decouple them. But I think it's a trade-off. That's something we probably can investigate more, So, but in Kubernetes, I would guess not for controller, right, is work and in somehow decoupled way. So go back to, so the use cases and do we want to add additional and node tents and then act on them? So firstly, I want to see, even for use cases, we want to have a more customer and a tent-based eviction. It doesn't necessarily mean we want to add more and tents even that way, right? And for example, is our stateful controller. It cannot simply say, okay, evict these ports if node is unreachable or not ready. Or even you add the tent and the toleration, the time, and it's hard to see. It may be check, right, on the workload status, depending on which stage the workload so far, right, in and the states, or the cluster and the conditions, other thing. Then look at the tent, combining all this, then we make a decision and whether or not, and evict the ports or when to evict the ports. From this perspective, that's firstly is, and what we want to propose is that we still want to have a way, right, to customize this and port eviction policy, right? Replace the default one. So in order to do that, if we have this both function mixed together, so is there any better way, right, to do this in particularly and since 1.27, we're going to remove this and flag how we're going to support this type of feature. Of course, in order to do that, we think it probably decouple them can provide us much more advanced extensibility and flexibility. Yeah, so that's my personal take on this. And of course, and in potentially future, and we could add more and tags, and we could argue this tags can be added to this node lifecycle controller, right? And just add additional more, but maybe I manually, right? I could just use command line and add more, and then my node tent manager can also act on that. So we decouple that, and I think probably from design or practice perspective would be work better.
So basically what you told is not some additional tent, more is like you want to replace today's logical, how we apply those existing tent to management node life cycle. So you have the customized these things. Okay, yeah. So I can see.
Yeah, I think this adding more tents probably. Yeah, I don't deep can add. Do we have that kind of use cases? If we have this, of course, we can support that. But at this moment, yeah, we think is even without adding additional tents, we just want to have a more advanced and complex policy. Yeah, to decide when to apply
the set of taints is pretty unbounded. Like it could be anything from kubectl that you apply on a node with the effect of either no schedule or no execute. But the taint name can be anything, right? Not necessarily unreachable or not ready. So I think as far as the code is concerned, yeah, they are two completely separate reconciler loops that are completely independent of each other today that queues based on their own logic. So yeah, the proposal is just can we decouple them so that they can be independently enabled of each other.
Any question, comments, or recommendations? How we should proceed, or put together a proposal, or file issue, or just submit a CAN?
Maybe start with an issue.
Okay.
Yeah.
Okay. Or we have file issue. Okay. More. Yeah.
And capture the information. Yeah.
Okay. Okay.
Oh, sounds good. Thanks.
Right.
Thanks. I hope your issue when you file, because in the past, under everything, the state, I feel, I don't know how customized you want, but in the past, we did discuss a lot of the state transition should be more intelligent. And I think there's even have the time, if I remember correctly, Derek, correct me, Vishnu even proposed something many years ago, something how to define those edge from the one state to another state, but we just never really finished those work. So please file the issue, then we can look at those issues. So I don't know how much flexibility you want, but there's the we being discussed, and if it's not that full of flexibility, maybe there's some way we could solve those problems. I don't know. So let's just start from the issue and the proposal. Yeah, next. Yeah, I can say that flexibility, but I also say that today our transition from the node state from 1 to 1 is not good. It's not to satisfy customers' needs. How about that way? So of course there's the problem. Yeah.
Okay. Yeah. Thanks for all those comments. We will definitely take into account. Yeah, we put together the proposal, other thing. Yeah.
So let's start with the issue, gather some feedback, notes, prior background on this, and then 128 we can see where we are. Thanks.
Yeah.
Right. Thanks, Deep and Yuan, for bringing that to the SIG. So next up, Mike Brown has a reminder about the probe granularity announcement. Mike.
Yeah, just a reminder. Need somebody to take a look at it. It's been around for a couple of releases. The idea is you can have more granular probes instead of saying start at 1 second and check every second. You could say start at 1.5 seconds or 1.2 seconds, right? Which would help in certain scenarios. Maybe 500 milliseconds is when it needs to start. And right now the defaults just don't allow for enough granular, configuration. We've got some code already written on it. We could set higher limits if that's what you guys want to do. It's okay. It's just in fast solutions, we in Knative, for example, we definitely need this so that we can do faster cycling on the probes.
Yep. Thanks, Mike. I can make a pass. I know it didn't make it to 127, but we can see what we can do in 128. Yep.
Yeah, exactly. Just got to get this one, got to get the enhancement going through so I can get the PR running. All right.
Right. So we had one topic from Sergey. Sergey, you're back. You want to talk about the annual report task?
Hi, sorry for being late today. Yeah, we will kick off annual report. I think we have a couple of weeks to fill it up. I started looking into this, and most of the topics are quite straightforward. And this year, steering committee even helped us to fill out some portions of it already. So if you have interest to participate in that, please let me know. Otherwise, I will be running some cleanup and filling up the section of this document. So yeah.
Great. Thanks, Sergey. So that brings us to the end of the agenda. Do folks have any other topics they want to discuss? All right. Thanks for joining then. See you all next week. Bye now.
Thank you. Bye-bye.